Alright. Y'all should have read 33 and 34 to at least answer those questions, which should give you a general idea of what I'm going to talk about today. Alright, there's three foundation systems that we deal with the most in architecture. Okay? They are a crawl space foundation, a full basement foundation, and a slab foundation, also called slab on grade. Okay? And I'm gonna show these on this video so people can see it real quick. Alright, and if you look on your screen, this right here, can y'all see that pretty good? This one right here is your slab on grade. This right here is your crawl space. And this one right here is your full basement. Okay? The differences are your crawl space is generally around 3 feet tall or so. Okay, 3 feet, 4 foot, somewhere up in there. Maybe even 2 feet. If it's not tall enough to stand up in, it can't be considered a full or a basement. Okay, so if you can't walk in there, stand up under there completely, it cannot be considered a basement. A basement has to be basically closed off with walls. It's got to be completely enclosed where you could actually live in it. So if you know those 4 types, or those 3 types, then generally, if you know basically the design principles of them, you can generally design any type of foundation you need. Alright, now let's talk about, okay, slab on grade, okay, it's generally one of the most used. It's just consists of a slab, generally about 3.5 inches. Sometimes it's more depending on if you're doing a commercial build or not. But generally it stays around 3.5 inches. And it consists of the slab and then some footings. Okay? So a slab on grade is generally slab and footings. Now these are generally poured all at one time. So it's called a monolithic pour, which means a single pour. Okay, so monolithic slab. The crawl space, this can be done in several different ways. Okay, one, it really consists of, we'd say, 3 different principles when it comes to a crawl space. The first thing you got to have is a strip footing or a continuous footing. Okay, that's the first thing you got to have. The second thing you're going to have is some type of wall. This wall is generally made up of either pure concrete or it's made up of CMU block. Everybody know what CMU block is, right? Okay, you should from construction materials. Alright, so, but what we generally like to call these are chain walls, or they consist of, they're also called stem walls. So they can be made of concrete or CMU block. But like I said, they only generally go up to about 4 foot, maybe 3 feet. It's just enough room for the plumber, AC guy, insulation guy, whatever, to be able to crawl up under there and install whatever they need to install. Okay? And of course the full basement, oh, and the third thing that a crawl space is made up of is generally it's going to have some kind of wood framing system up on top of the wall. Okay? You have to have some kind of wood framing system all the way up on top of the wall. And then the same thing goes for a basement. There's 3 things that really it consists of to create a foundation. That is the strip footing, The wall is the same way. It's either made of concrete or CMU block. And then you're going to have some kind of wood system up on top of that. Now, that can be wood or steel. Some people actually use steel members to go up on top of their wall. Okay? Now, can you think of a four system that we use a lot down here in South Mississippi? A fourth system. A fourth system would be pier or column systems. Okay. Now, most of the time when you talk about a pier or column system, the columns or piers are actually sitting down in what? Concrete. It's sitting down in concrete, and the concrete is generally a slab on grade, a monolithic pour. But the piers have to go down in their own individual holes. Okay? They have to go down in their own individual holes, and each hole has to be filled with concrete. Now I'm going to give you some handouts to show you a lot of this. I'm going to put them out on the website. A lot of different systems. But if you're doing a pier or column system foundation, the hole has to be 8-inch clearance all the way around the pole. So what that means is, if you have an 8x8 post, then your hole is going to have to be a minimum of 2 foot diameter, because you have to have 8-inch clearance all the way around the post. Generally, when you're going to have a post system where you're sitting up on timber piles, when you put it down in that hole, you have to have reinforcement drilled through the post and inserted in there, and it has to be sitting down in the concrete. Basically, what we generally do is drill 2 holes each way on a square column, okay? And when it sits down there, you pour your concrete. That's what the concrete adheres to. It kind of strengthens and grips that reinforcement in your pile.
You stick something inside, rebar?
They literally take and drill 4 holes in a square post. 2 on each side, okay, which becomes 4 holes. Then you take and cut you a piece of rebar. And generally your rebar, you want to cut it the length of the hole minus 6 inches. Because you don't want your rebar touching your ground. You don't want your rebar cutting your earth. Alright? So once you set it down there and you pour your concrete grabs a hold to that reinforcement and holds it down. The length of your piers, okay, or the length that the pole has to go into the ground is 1/3 the length of the pole itself. Which means from ground to where it's going to stop. So if it's going to be 18 feet tall, then your post has to go 6 feet into the ground. Okay? So basically they say 1/3 the length of the height from the ground to where it's supposed to stop at. And that's how you figure out how much it needs to go in the ground. Okay? And depending on where you're building at, depends on what that length is. I know over in Bay St. Louis, I did a job. They had to be up at an 18-foot clearance level. So that post had to be 18 foot tall. So I had to put it 6 feet in the ground, which means I had to get a 24-foot post. Okay? Yeah. So you can see that depending on what type of system you're dealing with and where you're dealing with, will depend on what system you go with. Now, there's some areas where you have to go piles. Even if it's not Depending on where you're at, there's a lot of code now that says you cannot enclose the bottom of a timber pile system, which means you can't put up full-blown walls. It has to be breakaway walls. So you got to put up like lattice around the bottom if you want any kind of privacy. They're not even wanting to allow a lot of storage areas underneath. It's becoming to where you can only get a certain square footage of the bottom can be a permanent wall setting. So most of them now have to be breakaway. So it means you can only put like lattice or some kind of stuff like that where the water
flows off the crawl space.
Well, it keeps so the water keeps flowing underneath if it does flood, and it doesn't pound on your system. It just flows on around.
If you got storage underneath there, 'cause I lived in a house on piles too, and just last year, if you got storage underneath there, it's got to be elevated.
Yes.
That way, you know.
So it's becoming a big issue down here, or a big design issue down here of how you do things.
There's no storage in the house either.
No. Now, depending on the type of system you do, there can be a combination of systems. For instance, the actual foundation plan that you're going to do for this house that y'all have done the floor plan on, it is a crawl space system. Okay? It was done right there in Gulfport. This is an actual house that was built. It was done right there in Gulfport. I only had to give him up, I think it was about 2 foot something. That's how far he had to go up for the flood level. So I put him on a chain wall, okay, or a crawl space system. I use CMU block all the way around it. And then on the center of the underneath, on the center of the house, I put in a CMU pile, which means I just took CMU and stacked them on top of each other to give it a load-bearing spot right down the middle of the house. Okay, and you'll see it when I pull up canvas here in a minute when I'm talking about. So basically, I took in the crawl space system, I took and put a pile right down the middle made out of the same CMU to help support what's going to sit on top of it.
So it still had to have a footing as well.
Yes, it still has to have a footing as well, what are those footings called? Do y'all remember? Spot footings. If it's a little square or rectangular footing that's sitting individually by itself, it's called a spot footing. Now, there's a lot of things a lot of code that still governs your foundation. Before Katrina, you could put number 4 rebar in your slab. After Katrina, you have to put number 5 rebar in your slab now. Okay, that's code. You cannot use anything under number 5. Anchor bolts, which I think I've told y'all. Didn't I tell y'all about that on the
They added more.
foundation or the floor plan we was going over? Anchor bolts used to be every 48 inches on center. And anchor bolts is basically the bolt that goes in the slab and sticks up in your bottom plate of your floor or your wall. You connect to it. It used to be every 48 inches. Now it's every 18 inches on center. And you have to put one on each side of an exterior door. Okay? So, if you have one that falls out like 8 inches from a door, well, you still have to put that one plus the one next to the door. Okay, so it's 18 inches plus you have to put one on each side of the door.
What was the point of it?
It's beats me because I did a lot of analysis after Hurricane Katrina on slabs when I was working for that structural engineer, and the one thing that was constantly always on the slab was the bottom plate, even at Hanger bolts at 48 inches on center. So I have no idea what the justification was by moving them closer together.
Somebody steals more than 8 bolts.
This is
Somebody
it.
must have run across the house with a bolt and twisted or something, while they added.
Now it's my cousin on the country.
That's what I'm saying.
Yeah.
Somebody's cousin.
All right. Another thing that's a big thing when you're designing houses, I don't necessarily show them, but I call them out a lot. If you actually work for an architect, you'll probably have to actually show them. But there's hurricane straps, joist hangers, beam hangers, rafter clips, and so forth. And you'll see on the set of drawings that I'm actually giving you to do, I call them out. With this type of system that we're doing, where you have a crawl space and then you have a wall sitting on top, or wood members sitting on top of your CMU wall all the way around, you have to put hurricane straps that goes from basically the chain wall all the way up to the stud. Okay, it's called out on there, you'll see it. One of the reasons why is to try to connect from all the way up, down to your foundation. That's what they're trying to do. Because you'll see the wood member that goes on top of the chain wall is actually bolted down to the chain wall. So they try to have a system that's connected all the way up throughout the thing. Rafters. Every ceiling joist, every floor joist, every rafter has to have a hanger or a rafter clip on it. Okay? Now I think on these drawings, that's the one thing I actually forgot to call out was the rafter clips. But it will not pass code unless they do it. Now, is it that big of a deal when you're doing residential? No, because the simple fact is your contractor is responsible for putting them on no matter what. If you're in an architectural field, you're going to want to make, or if you're doing a commercial building or something, yes, you want to make sure they're on there. Okay? So, now what do we show on a foundation plan? Here's the main things you want to show. You need to show every edge of concrete. Okay? You want to show every edge of concrete, which means if there's any kind of change in direction or change in elevation between slabs, you need to show the edge. Okay? You need to show the footings. All footings need to be shown on the foundation plan. That's spot footings, strip footings, whatever. If it's a footing, it needs to be shown. Of course, on a foundation plan, you're going to have section bubbles, because you're going to have to draw some sections from your foundation plan. Now, if it's a crawl space or basement, you have to show all framing members also, as far as floor joists, any kind of piers that's holding up any beams, any of that has to be shown. You'll see on this one, I actually have it. You'll see it has shows you how far spaced the joists are supposed to be. And I'm gonna see if everybody catches. But I will tell you, anytime you do a floor system, floor joist system, the first joist, okay, the first joist has to be or let's just say it this way, 15 1/4 inches from the outside edge to the next joist, or to the center of the next joist.
15 and 1/4.
15 1/4. From the outside edge of the wall to the center of the first joist has to be 15 1/4. That's the same way if you were going to build ceiling joists, rafters, or anything. The first one has to be 15 1/4. Same way with a wall. If you're actually constructing a stud wall, the first stud has to be 15 1/4 from the outside edge to the center, and then you can lay it out from there. Okay, that's from outside edge to center. Now you probably wonder why.
Said so.
Nope, not because I said so. Think of it like this. If you had two studs, okay, let's do it. If you had two studs, let me find this and this will work. All right, if you had two studs, you put a sheet of plywood up between them, what happens? When you put a plywood on them, they got to go center to center, right? So you can put the next piece on there, screw it down and all that, right? In the middle of the wall, it sets 16 inches on center. That's fine. But think about putting a piece of plywood up on the edge. Do you put it at the center of the stud on the edge or not? The very first one. No, the plywood has to go all the way out to the edge. So you just lost 3/4. So you basically got to move your whole system 3/4 this way so that now your plywood fits all the way down. Does that make sense? So you're moving it over 3/4 means you got to move your first stud over 3/4, and then it falls out. Then you do 16 inches on center from there on out. So you'll see, you should notice when you go to do this foundation plan that I actually have that shown. Okay? So I'm going to expect you to draw it that way. When you have a crawl space or a foundation system, you can't just lay joist on there all the way across without having a rim board on there. Now what is a rim board? Basically you're taking the same size material that you just put on the joist and you're nailing it to the very end of the joist all the way down. Why? Well, it keeps your joist from trying to lay over one way or the other, or twisting one way or the other. It's basically connecting them all at the ends, and it gives them that lateral, that bracing kind of is what it's doing. You'll see that on the drawings, okay? Really pay attention. Don't just draw these. Understand what you're drawing and why it's there. Because I know probably half of you is going to want to draw house plans later on in your life for people. So you need to know why you're doing it. Why are you drawing this? What is the reasoning? And then generally at the first joist and the very last joist on the other end of the wall are always doubled up. Okay, they're always doubled up. Because it's your very end, is where all your load's going. It gives it a little bit more bite. Okay? Because you don't want all your load resting on one little 1.5 inch piece of wood, do you? So you put two there to kind of space it out to give it more bite when you're trying to hold it down. Alright, you will see on my plan that I show all edges of slabs solid. Okay? I show all edges of slab as solid. You'll see all footing should be shown as dash lines. If you have a crawl space or basement and you got a floor system on top, then you need to show whatever your wall's made of, that the foundation wall, if it's concrete or CMU, both of those should be solid lines. It should be hatched. The walls should be hatched to show what they are. And then, of course, what I do is I make my framing members that are sitting up on top of my wall. I try to get a unique line system going and use that all the way through it. You'll see when you get on there, I actually use a phantom line.
There's lines for hands.
Two dashes. Two dashes, then a big dash, and two dashes, and a big dash. Okay? That's just what I use. There's some people actually just use solid lines to represent them. I try to use it just to make everything, when you look at my plan, you can tell the difference from one thing to another. Okay? Now, if you have a floor, or if you have a slab sitting on top of your CMU wall or concrete wall, then the inside edge of your wall has to be shown as a hidden line. Does that make sense? If you have a wall, right, and then you have a slab that covers up that wall, your inside line of your wall has to be shown as hidden. Okay? Because you can't see it if you stand on top of that slab, can you? You'll see that when you look on my foundation plan. You see I have all these different, I tried to create a couple of different scenarios for you on this one. But I went ahead and did the hardest one for this one as a crawl space so that you can see how it works and all that. Now I'll give you more handouts. You just keep watching. I won't give them all to you just for this project, but what I want to do is give you all the different types of scenario, and I won't be able to get all of them. But I'll try to give you a couple of details of each type of system, okay? So that you can see what the details should look like and so forth. All right? Because like I said, when we come down to the final project, you're going to have to figure out what goes where, how does it work, and all. Matter of fact, next week, see, I think we have 9 weeks left. 8, 7, something like that. The next week, I'll cover elevations. You will draw the elevations. Then the week after that, I will cover electrical and mechanical. You will do both of those in 1 week. And then after that, I'm probably going to give you a set that you got to have done in like 2 weeks of a complete set, but it's going to be copied. It's not going to be like you figure this out. I'm just going to give you everything. You go through there, complete the set. And your final set is what I'll give you 2 or 3 weeks to do when you actually got to figure it out yourself. Okay? So your next one I give you will actually, I'm going to try to give you a different type of system to use. And that way you can see a different system. Now, be watching as you do this next assignment. You're going to do the foundation plan. Then you're going to have 2 sheets of details you got to do. And they're all going to be foundation details. Be watching Canvas. Because if I find any kind of error that I may have, not really an error I made, but something I may have left off, then I'm going to put a little sketch out there and tell you got to add it to your drawing. Okay? And there's a couple of them I actually know right now that I left off on purpose. so I can give you sketches to do. So I'm basically going to treat you like this is the company, and I'm going to go back and go over my design, and if there's some things missing, I'll give you sketches for it. Okay?
Party with fire for Saturday.
All right. Any questions on? I mean, there's a lot to foundations, but I'd stand up here for 3 hours just trying to draw the different scenarios we get into. So instead of talking about it all day, I'll just kind of give you handouts to show you. All right. And when I give you the handouts, I'll try to give you a title of the situation, like slab on grade, where main slab meets porch, or something like that. You know, try to tell you exactly what this consists of and all that kind of stuff. Any questions? You don't have any?
Get out of the drawing, Greg.
No. I got half the class marked up. And it ain't looking pretty. I'll just tell you that. Half the class I got marked up was more or less, it's all just settings. Text height. All that kind of stuff. That's probably what I've taken off the most for so far of the half the class that I've went through. Okay. Believe it or not, that is half of what I've so far found wrong. Now I did find some people had some just putting dimensions on there. You didn't even have a dimension into the right spots and just careless stuff. There's a lot of stuff I found.
I'm still trying to record.
Yeah. So I'll try to finish them up this week and have them for you for next week, for you to check what I've taken off on this group set compared to what you got to turn in next week. Okay, so next week, both the foundation plan and the details are due. And I'm going to go ahead and show you the 28th. By the end of class, but I am going to lecture again next week. Now listen, the last time I just printed it out and gave it to you from the actual set that I did. But this time, that's what I got in here late for. This time I actually took the time and made everything to the exact standards that I gave you on the last set of drawings. Okay? So this is the same text height I told you to put everything. You see how everything looks? This is the way yours should look. This is the foundation plan. These bubbles right here. I'll go ahead and put out, I don't think Design Center actually has one of these, or do they? Y'all remember seeing one? I'll actually put this one out here on Canvas for you. But I'll put it, I'm only going to give it to you 1-to-1, so you're going to have to adjust it to whatever scale it's supposed to be. Now, here's one piece of advice I'm going to give you. This text bubble is drawn to where the text is 1/8 of an inch. But what is your text supposed to be? 3/32. So here's what I suggest you doing. I would take this symbol when I give it to you, insert it to my drawing, and I would scale it up by the scale factor of the drawing. I'm not going to tell you how to do it because you should already know. Once you scale it up, I would only do this one time. Once you scale the first one up, then you're going to scale it again. Okay? You'll scale it one more time from the height that it's supposed to be at, the 1/8 inch supposed to be at that scale, down to the height of what 3/32 is at that scale. Because you remember everything, dimensions and all that is 3/32, right? So you scale it the first time, you scale it by the scale factor. The second time you're going to scale it by what the text height would be at the scale factor it is, what 1/8 inch text height would be at scale factor, down to what 3/32 would be. Does that make sense? You'll see it. If you don't scale it down, your bubble is going to be a lot bigger than this bubble. So that should give you a red flag. Something ain't right. So you're going to scale it twice. What is the second time you scale it, you're going to use the scale command, but does anybody remember the option that you got to use to scale it from one to another? Reference. So you'll use scale reference to do it the second time. So the second time you scale it, write this down. Take 1/8, multiply it times the scale factor. That tells you what text height would be at that scale at 1/8 of an inch. Okay, say 1/8 times your scale factor. That gives you your first reference number. Then you're going to take 3/32 and multiply it times your scale factor. And that gives you your second reference number. Okay, so you're going to use those two numbers for the second time you scale it. The first time, you got to scale it up by your scale factor. Now you see where all those little things that we've done over principles and intermediate, all the manipulating, this is where it all starts coming into play. The reason you're doing that is to keep your bubbles proportionate with the rest of your objects. Because if you scaled this up, since I have it drawn where the text is 1/8 of an inch, if you were to scale this up, okay, and just leave it at that, it's going to be huge. The text is going to be huge. So you got to get it down. Notice that this text right here, the 1.0 and 2.0, is the same height as that right there. Okay? That's both 3/32. Now this one's a little larger, but my rule of thumb is to keep the smallest text in an object at 1/8, and everything else goes bigger. See what I'm saying? So these two numbers down here are 1/8, and I'm gonna give you this so you don't have to worry about it. Drawing it. I'm gonna give it to you, and then you just got to do all the scaling and all that. So all of this is 3/32, all this text. This is even 3/32 right here. The note, see owner for placement of blah, 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 blah. Where it actually says the word notes, that's 5/32. Down here at the bottom where you see the title foundation plan, that is 1/4. And right here where you see scale 1/8 inch equals a foot, that is an eighth of an inch. Notice over here, I already have the title block filled out for you. If you don't put, and I've seen too many people didn't do this right. I got to see something there. All right, now let me explain to you real quick what these bubbles mean. The top number tells you which section you're looking for when you get to the detail sheet. The 1.0 on the left-hand side tells you what sheet this section was cut from. The 2.0 on the right-hand side, or the 2.1 on the right-hand side, tells you what sheet it's located on. Okay? That's what this bubble means. This is very important to make sure these are right, because if you are actually doing a huge set like we did on, like I had a hand in on the Coliseum after Hurricane Katrina, we had over 100 pages in our set of drawings. So your section cuts you had to go through, and literally at the end of the project, before we considered 100% complete, we went through, printed out a set, took a highlighter, and checked every bubble to every sheet. Made sure it was at the right sheet, made sure it was the right numbers, everything. Okay? It is so important, because if you put wrong bubble numbers, that's how jobs get screwed up and people build stuff wrong. The top one is the actual detail number itself. The bottom left-hand number is the sheet it's cut on, the sheet you actually put the section cut on. And the bottom right-hand number is the sheet that is actually, the detail is drawn on. Okay, you see on here where I'll talk about it says 2x12s treated lumber at edge only. You can see right there, there's 2x12s, and down here there are 2x12s. If you look at this section number 4, and you look at this section number 3, it'll actually show that on there. The rim board, what I was talking about a while ago to help keep your joist from twisting, is actually at the ends right here where the joists stop at. You'll have a rim board there and a rim board on the right hand side. Okay, you can see how my line types go. There's my dash lines, that's my footings. There's dash lines, that's more footings. You see this hidden line right here? This is actually the wall underneath, showing you, hey, there is something underneath here. Go to this section, number 5, and find out what's going on. So anytime you have a different situation or going on, you have to give a detail of it. You see right here in the middle, there's your piles. Okay? I gave a section cut on it. You see it tells you there's 2x12s running across here, all the way across. This way? You do. Tells you right here, all these lines going across here that are phantom lines are treated 2x12s at 16 inches on center. But then notice up here there's one dimension actually giving you this dimension, 1 foot 3 1/4. Remember, the first one always has to fall 15 1/4 from the edge, and then the rest of them are 16 inches from there. Okay. This detail right here says 8 foot max typical, which means these are all evenly spaced. Okay? These are all evenly spaced, so you're going to need to make sure yours are evenly spaced.
That's awesome.
That's 8 foot max, which means you're going to pull a measurement across here, find out what it is, and divide it by the equal spaces to give you where those centers are. But what it's telling you is if, let's say from here to, let's say I called out 4, or I only showed 4 on here. And when you went to figure it up, it came out to be 8 foot 6, 9 foot, or 10 foot apart. You know you had to throw another pier in there because there can only be an 8 foot distance in between them. Okay? The reason the 8 foot distance is there is because of the material I used. If you had steel beams going on there, or if you had a glue lam beam going across there, you could have got a longer span. But since I only used 2x12s, you couldn't get that long of a span. And the reason I do that is because a lot of times, sometimes I can't get away with it. But the reason I do that a lot of times is because it's material that you can find locally. It's not something you got to specially order. Okay? You start getting into glue lam beams and steel beams, you'll have to specially order a lot of that stuff. So I try to stick to what people can get right here from a local lumber yard. Alright, you see dimensions, I give only dimensions basically for the slab, edges, and then any pertinent information to show, you know, maxes and typicals and that kind of anything. So only any kind of change in lengths of materials or something like that I give dimensions on. Alright. The detail sheet, like I said, there's 2 of them. You can see how much information goes on these details. Okay? Basically, if you look at this, you draw one, you copy the information to the other, and then copy it to the other. This is all a bunch of almost duplication of information is what it is. But you're showing all the different scenarios that's going on with it. Okay? So that's the first one. And here's the second one. Remember, these are all just foundation details. When we go over elevations next week, you're going to have more details to add. Okay?
Now, when it says 2 by 8, dimensions by 8 inches, or is that just?
You better use what you learned from construction materials.
That's what I was thinking of as a 2 here.
Okay? It's called out as a 2 by 8 because when you go to order it, you don't go in there and order a 1.5 by 7 1/4 inch board. You go order a 2 by 8. But when you draw it, you better draw every bit of this stuff to actual dimensions. Which an 8-inch block is not 8 inches, is it? Does anybody remember what it is? 7 5/8.
Oh, don't hit me wrong. 2 inches would be more than.
I'd say go back and review all your construction material notes. Y'all haven't had it yet.
Yeah.
He didn't have it.
Why you ain't taking it right now?
I said it's gonna be next week before we ain't got nobody to take it this morning. We did our schedule and.
Alright. So you can see yours better look identical to what I've given you. And when I mean identical, I'm going to take each one of your drawings, and that's why it's taking me so long to grade your other ones. I take mine, set it on top of yours. If it doesn't match up, I know you did something wrong. Okay? So there should be a call out for everything on here. Any questions?
Said this is all due next week.
All due next week. So you got a foundation plan. Okay, your foundation plan will be turned into one file or submitted. You can do this all in one file. All right, you can do this all as one file. But once you do the foundation, matter of fact, you already have your floor plan done, right? So you're gonna go into the same floor plan file now and create your foundation and your details. But when you go to upload it, I want you to upload the same file to 2 different Dropboxes so that I can give the grades out. You're going to have the foundation Dropbox, you're going to have the foundation details Dropbox. So basically you're going to get 1 grade for the foundation and 1 grade for the details. Or 2 separate grades, I guess is what I'm trying to say. Huh? Yeah.
I got a lot of stuff to do, just when I get started.
Yeah, considering I can design an entire house and have it completed in a week, you should be able to do a foundation and details.
Yeah,
Been
we're not
doing this
cheap.
for like
I'm not cheap.
10 years.
Yes.
Okay? Just remember, when you do one of these, for instance, like this one right here, okay, look at this one and compare it to this one. What? Copy? Copy? So if you can't do these in the foundation plan in 1 week, you're just lazy.
That's all, that's all. You know what, you build your
But-
slab and bricks are the same thing, tell your employers.
Exactly. Every bit of this is almost is identical. You're just adding maybe, you might be adding another note or taking a note away. You just got to pay attention to that. Okay? The foundation system you already have partially drawn already. Where? Floor plan. Copy the floor plan over, erase all the information, just leave where your walls are or your slab edge is. Hey,
Floor plan drawn back and.
lazy if you can't finish is all I can tell you.
Alright, simple as that, go be on unemployed. Hey, hey.
All right, any questions?
You should probably check your inbox.
I'm not worried about the inbox. 'Cause how many times I got to tell people, do not send me a message through the inbox. Email me. I'm not looking through all that because a lot of us just jump. I don't even want to look at. Class party. That won't be till the spring. Well, in the spring we always do a big day where we'll order pizza for everybody and just feed y'all. Or we go eat something.